just a tiny bit more. It's mostly stuff. Balancing redox reactions with the oxidation. I mentioned that this is something that you can do when we do this to every we use the to connect them just like I've done previously. We talk about how many electrons are transferred. You'll see the plus 2 minus 3 there. Use coefficients to make the total increase in oxidation number equal to the total decrease in oxidation. So in this one, they had this plus 2 right here, right? And of course, you got a minus 3 down here. So our common denominator, we're going to multiply the 2 by 3 to get to 6, like 3 by 2 to get to 6. And so since this one is the one that needs to be multiplied by 2, then we have F, that should be 2 FeO3S. There's a 2 Fe. And then multiply this other one by 3, so that's 3 CO2. There's a 3 CO2. So again, this should be a 2 right here. Have to multiply everything. Go, awesome. But that's what we're doing right there. And so this is really no different than what we talked about previously. So that we already have. We then need to balance for oxygen. So we need to make sure that we have the same number of sorry. So they indicate how many, what the charge is going to need to be to make that work, right? And then they say, okay, how many FEs do I have on both sides? I have 2 FEs on one side, 1 FE on the other, so I'll multiply that by 2. So this then becomes a 2 out here. We have 1 carbon on one side, 1 carbon on the other side. Awesome. I know that I have 3 plus 1 is 4 oxygens on the reaction side, 2 oxygens on the product side. So I'd be adding 2 H2O to this side. We then balance for hydrogen using H+. I know that I have 4 H's that I have there. I have none on the other side, so I need to add 4 H+. And then we need to make sure that we've got the same number of electrons. So Fe2O3. Just checking. It feels weird to me, but okay. They multiply this by 3, and that's how we get the result that you see down. And notice we have 1 and 2 there, so that's exactly what I'm expecting. Again, I don't like this. It's not comfortable to me because we're doing everything in one step, one space. It's not someplace I like to be. So that is not something that I do. But this is a method that you can use. It's perfectly acceptable. I will give you this caveat. Come on. Come with me. I will not expect you to use one method or the other when you do this. You can use either, but I'm only going to use the half reaction. It's the only one that works for me. But like I said, I can follow the other one if I need to do it. Like if you guys do it on a test, I can grade it. It's just not easy for me. So I may not be able to help much in walking you through how to do it. So if you've made a mistake partway through, it may be very difficult for me to identify where that mistake was made. And so my feedback on it, just if the file or the lab says use a specific method, you can ignore it. I will grade it as right as long as it's spelled correct. So there's one caveat. And I think I already said that. So questions, comments, problems. Again, I hope not. I have more examples, and these are more examples that I would like to work with you guys. So PB reacts with MnO4 minus to produce the PB ion and the Mn. Balance the equation using half reaction method and stated in acidic solution. Right. Okay, let's give us some paper. And again, since I'm no longer looking at my slide there, here so that I can so PB reacts with MnO4 minus to give me the PB ion, and it's PB2 plus, and the Mn ion is Mn2 plus. Okay. So those are the ions that I'm looking at. Balance the equation using half reaction method and, as always stated, in acidic solution. So my two half reactions, PB goes to PB2 plus, MnO4 goes to Mn2 plus. We have balanced this MnO4 a number of times already. So I'm going to go back and say, okay, how did I do that? Flip back through my slides. I didn't do it there, but I did do it. Nope, not there. And not there. Come on. Ah, here. We did it here. I'm going to slide up a little bit so I can see that reaction, the whole thing. So the 8H plus MnO4 minus. I'm going to cheat. Copy that. It's messy, but I'm going to do it. And I know I missed the 8. I see. Put that there. And then the H2 over here. It fits. Go awesome. Copy and paste is good. And then 8H plus 8H plus 8H over here. Product. And then 1 Mn on both sides. I have 4 oxygens. 8, 7 plus the 5 is 2 plus, and 2 plus 1. So that is completely balanced. And we've talked about the fact that we can use it again. So we're going to be using it again. This is your first example of how I do that. Now, with this one, my PB is balanced. I have 1 PB on both sides. I don't have any oxygen. I don't have any hydrogen. So I only need to deal with the charge. So I have PB going to PB2 plus 2E minus. 2E minus in this one, 5 in that one. I'm going to multiply by 2 here. I'm going to multiply this one by 5 to get the same number of electrons. I get 5 PB goes to 5 PB2 plus 10 E minus 16 H plus 2 MnO minus plus 10 E minus goes to 2 Mn2 plus 8 H2O. It is very common to have to multiply this one by 2 because it's a 5. Very common. Okay, awesome. Cancel anything that's the same. 10 electrons, 10 electrons. So 5 PB plus 16H plus 2 MnO4 minus 5 PB2 plus 2 Mn2 plus 8 H2O. The space has gotten yet again. PB H MnO charge. I have 5 PB, I have 16H, 2 Mn, 8 O. I have 5 PB, 2 Mn, 16H, and 8 O. My overall charge on the reactant side over here, I have 16H plus minus 2 is 14. Here I have 5 times 2 is 10, plus 2 times 2 is 4, which is 15. So everything's balanced. Go awesome. That was not nearly as bad as it has been in the past. And again, that's because I can reuse one of those to make the rest of this not as complicated. So if you have those things, use them. And of course you do for most of this because of the standard reduction potential tables. So the ones from the exam habits I showed you before. Okay. So there's that. Okay, that's exciting. Let me scroll up a bit and let's talk about the next one. Because there are a bunch of examples. I have I minus plus OCl minus goes to I2 plus Cl minus plus H2O. And this is in base. Okay. So I minus is going to go to I2. That's one of my half reactions. My OCl minus goes to Cl minus. And I don't know where that H2O needs to go. I have no idea where it needs to be. So I'm not going to put it in there for now. I know I better end up with one. That's how this should work, but I don't know where it's going to go. Now, I have one chlorine on my reactant side, one chlorine on my product side, so that one's good. But I have 2 iodines here and 1 there, so I'm going to multiply that by 2. Okay, let's do balance. Oh, H2O. No oxygen in this reaction here, but I do have oxygen here. So I have an OCl minus, going to Cl minus, plus an H2O. Oh, look, that's where it's supposed to be. Go awesome. I have now screwed up my H plus. H with H plus. So I'm going to ignore that iodine for a minute. I added 2 H's over here. So 2H plus OCl minus goes to Cl minus plus H2O. 2 minus goes to I2. Now I need to look at charge. So I have 2 negative here and nothing here. So I'm going to add the 2 electrons on the product side. 2 plus 2 E minus. We have 2 H plus and an OCl minus. We have a negative here and a negative here. We've added those 2 H pluses. So we need 2 E minus plus 2 H plus an OCl minus goes to Cl minus plus H2O. 2 electrons, 2 electrons. 2I minus plus 2H plus OCl minus goes to I2 plus Cl minus plus H2O. But I can't stay with that H plus because I'm on the base. So I have 2I minus plus 2OH minus plus 2H plus OCl minus goes to I2 plus Cl minus plus H2O plus OH minus. Now, these two become 2H2O, and I have an H2O here, so this becomes 1 H2O here, and I cancel that. That then leaves me with 2 I minus plus an H2O plus OC minus goes to I2 plus Cl minus plus that's 2H. And that's my overall balance in base. Okay. That's how we take care of it. Questions, comments, problems, I hope not. But again, that's our situation. Sorry. Still doing examples. Al plus ClO4 minus goes to Cl minus plus Al plus I just, in my head, I'm thinking, didn't I do something with that CO? And not. Thought I remembered that I did, but I hadn't. So, okay, fine. So let's do this. I have an AL goes to AL3 plus. And I don't know why I write it. Sometimes printed, sometimes cursive. I have no idea. ClO4 minus goes to CL. Okay. I have one AL on both sides, reactant and product. I have one Cl on both sides, reactant and product. I have 4 oxygens over here. So now I need to deal with that. So I'm going to have my Al into Al3 plus. I act like you know exactly what I'm doing. I keep forgetting that I need to label the steps that I'm doing. So Al goes to Al3 plus, and ClO4 minus goes to Cl minus plus 4H2O. I then screwed up the protons, so now I have to do H with H plus. This one doesn't change. I'm going to need to add 8 H plus the Cl minus goes to Cl minus plus H2O. Now I need to do charge. So I have an Al go to say Al3 plus. And I have 3 electrons. Here I have 8. That's 7. And there's 1. So I actually need to add 7 electrons into this to make that balance. Yeah. No, wait. Sorry, that's 8. So I have a negative here, I have a negative here, so I need to add 8. E minus plus 8H plus Cl minus Cl minus plus 4H2O. So now I have 8 here, 3 there. Oh, that's easy, isn't it? So 8 times 2 is 16. Oh, that doesn't work. So let's just go 8 here and 3 there. If it's too much, I can always reduce it. So 8 Al goes to 8 Al3 plus 24 electrons, 24 electrons plus 24H plus 3 Cl minus goes to 3 Cl minus plus 12 H2O. So I have 24 electrons on both sides, so I'm going to cancel them both. I don't have any H plus in common. I don't have any H2O in common, so I now can add 8 Al plus 24 H plus 3 Cl minus goes to 8 Al3 plus 3 Cl minus plus 12 H2. And 8 is not divisible by 3, so I think we're good. Let's do a little check. Al, H, Cl, O, and charge. I have 8 here. I have 24 there. 3 there. 12 there. My overall charge here is 24 plus minus the 3, so it's 21 plus. Here I have 8 Al, just 24H, 3 Cl, 12 O. 8 times 3 is 24, minus the 3, 21. Ugly, but go cool. It takes a bit of time. Now, I realize that it seems like I go through this really fast. I'm sorry if it feels like I'm going too fast. I'm trying to slow down, but it gets rolling. sometimes forget that I need to take a step back and do it. So that's why I'm trying to stop and label things so that you know what it is that I'm looking at. Let's talk about a couple more examples, and then we're going to have key takeaways from this, and then we'll talk about the next topic. So, our next one, Zn plus B03 minus B minus plus Zn2 plus. I'm going to do the Zn goes to Zn2 plus first because it's the shorter one. The BR03 is going to be going to have corrections to it because of the oxygen. So here are my half reactions. And now I'm going to balance for anything that's not oxygen. I have one zinc on my reactant side, one zinc on my product side, so that's good. I have one bromine on my reactant side and one bromine on my product side, so that one's good. And now I'm going to do oxygen with the H2O. And I'm just going to rewrite this again. And 3 H2O. H plus. This is the same. I have 6 hydrogens that I introduced with that H2O. So I have 6H plus Br3 minus goes to B plus 3H2O. Okay, so now I need to deal with charge. Zn goes to Zn2 plus 2E minus to get 0 on that side. I have 6H plus and 1 minus there. I have 1 minus on the other side, so I need to deal with the 6H plus difference. 6 plus difference from that. So I'm going to add 6 electrons. 6E minus plus 6H plus BR03 minus. Going to give me, I think it's Br minus and 3H2O. Br minus H2O. 6 electrons. I need to multiply this by 3. 3Zn goes to 3Zn2 plus 6 electrons. Cancel those 6 electrons. I have Zns. I don't have anything else in common. So I'm going to add 3Zn plus 6H plus BR03 minus. Let's do 3Zn2 plus B minus plus 3H2O. Zn H BR and charge. I have 3 Zn, I have 6H plus, I have 1 Br, and I have 3 O. My charge on this side is 6 plus, I have 1 minus, so this is 5 plus over here. I have 3 times 2 is 6 for my charge there, 1 minus, so it's 5 plus charge. I have 3 Zn, I have 1 Br, I have 6H, and I have 3 O. Yes, awesome. We did that. Cool. Okay. Couple more. Solid copper reacts with MnO4. You know what? I'm going to do this. I'm going to say that right now, I'm happy with where we are. Now, if you're not happy with where we are, then I will put the answers for these last few examples onto D2O. But we've done a bunch in base. We've done a bunch in acid. Did I do? Hold on. I gotta check. Yes, I did the correction. Sorry. I had to make sure that I had done it in base. So we've got a bunch of things that we've done. I'm looking at this copper. Solid copper reacts with MnO4 minus an acid to produce MnO2. what I was thinking. That's not going to balance. There's no copper on my product side, so that's not going to work. Is CrOH3 plus the Br2, that can work, and we can do that. And I can, like I said, I can put up the results for those. Okay. Couple of things that we need to talk. Each half reaction is completely independent of the other. So if I balanced one half reaction before, the same balancing applies in the next case. Okay. So the standard reduction potential tables have balanced half reactions that you can work with. You need no justification for that. If I ask you about something on the test and it's in that list, just pull it over and say standard reduction potential. Not a big deal. So tables of balanced half reactions do exist. You can use those half reactions to skip a large number of the steps. We will show you that next lecture. Okay, examples of that. The part that's always required is to make sure that the E minus lost or the E minus gained. Balancing a basic solution is a simple change from H plus to OH minus by adding the same number of OH minuses to both sides. And you must have an oxidation and a reduction to make the balancing work. One must gain electrons and one must lose electrons. So if you're working your process and you end up with all the electrons on one side, there's a mistake somewhere. And I can't tell you how many times that's how I find a mistake that I've made. So those are my takeaways. Does anybody have any questions, comments, problems, concerns, any of that stuff? I hope not. But we're going to take a pause here. There's another part to this lecture. We're going to be talking about voltaic cells. We're doing that because we're getting to the lab. So we need to make sure that we have information for lab 7, which is this week as well. So I'm going to stop sharing. I'm going to stop recording, and I'll come back. Talk to you guys soon.